This is step number 4 of the project. And in this step, we are going to get all the input commands from serial on the Arduino side, and then make sure that those commands are correctly executed on the hardware components we have connected to the Arduino. So we have already initialized all the pins, everything we can. So we have initialized the serial communication. We can send also the button pressed command or message when we press on the button. Now what we can do is in this void loop, well, we have this first action, which is to send something to the serial, and you can see we don't have any delay here, so it's not blocking, it's gonna be very fast. We can add after this the code to check from serial if we have received something. So if serial.available greater than 0, then we can get the command with, let's store as a string, cmd is equal to serial.read string until \n with just one single quote character. Once we have this command, well, let's see what kind of command we received. So if cmd, and now, well, I'm gonna come back to the protocol we have defined here. You can see we have all those commands to handle. So open door, close door, print text, play buzzer, and set LED. So let's write the code for all of that. So if the command is equal to open door, okay, so if it's equal exactly to open door, then we can do something. I'm just gonna write all the else if first. We have close door, okay, and we're gonna close the door with the servo motor. Else if command, so here this is an exact command here, this is a command that starts with this, and then we have some text or some variables we want to extract. So for those commands, I'm going to do command dot starts with print text and colon and 2 parentheses to close. Then we have, so else if command dot starts with, we have play buzzer colon, and the last one command dot starts with set LED colon. Okay, so as you can see, if you add more commands, it doesn't get more complex. You just have one more else if, and that's it. Your program is not gonna be more complex. And let's do an else, and here I'm gonna give you another best practice. Well, let's say you have received a command, so something that you can read from serial, and it doesn't correspond to any of that, which means you have probably received some garbage command. And in that case, what you can choose to do is to also clear the input buffer. Okay, because if you have received something that is wrong, maybe you still have some bytes that have been received and that are in the buffer that you're gonna read next. And so what we can do is do while serial.available greater than 0. Let's actually put some parentheses. And we do serial.read. So the same thing we did here to clear the input buffer, we do it here in the else. Okay, so the else, you could choose different behaviors. You could find some way to print some errors, so on the LCD screen, or maybe send back a command to the Raspberry Pi that's going to process it and print it that you have sent an error. Here we just choose to clear the input buffer so that the next time we enter the void loop, we give a new chance for the Raspberry Pi to send a correct command. All right, let's also save this as the step number 4, so I don't forget. Okay, save. Let's just verify, let's just compile to see that we have the correct structure. Done compiling. Okay, so the if structure is correct. Now let's do the commands one by one. So we have already initialized everything. That's going to be quite easy. So if we have the open door command, what we do is simply to send the servo to the position which we have defined here, the open door position. So I'm going to do simply servo.write open door position. And if we receive the close door command, we just do servo right with servo close door position. Okay, those are actually the simplest commands to execute. And well, here what we do is we directly send the command, okay, to the servo. What you could do as an improvement, I'm not gonna do that here, but you can do that as an improvement, is to make the servo go a little bit slower with a non-blocking delay mechanism in the void loop. So you could have another part of the code here that's going to compare the current angle of the servo with the target angle and check if it needs to move a bit, and every time wait, for example, 10 milliseconds before it moves for 1 degree, okay? But here we directly send the command go to open door position, go to close door position. All right, now when we receive print text, what we do, so the first thing we do is command.remove. Let's remove the print text. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we're gonna remove from 0 to 11, and we are left with the text to print. So we can do lcd.clear to remove anything, lcd.set cursor 0 and 0, and then lcd.print cmd. I'm going to add an improvement here because, well, you're going to just print on the first line, and you have 16 characters on the first line, 16 characters on the second line. And here we just write on the first line. So everything after 16 characters is going to be truncated. What we could do is that if you receive a string that is more than 16 characters, you print the following on the second line. Okay, so you can use all the 32 characters. And so what I'm going to do is I'm going to do string line 1 is equal to command.substring. I'm going to take from 0 to 16. And then string line 2 is equal to command.substring from 16 to the end of the string. Okay, so I still clear the screen. I set the cursor to 0, 0, and then I print not the command, but I print line 1. And then I do lcd.set cursor 0, 1 for the second line, lcd.print line 2. Great, so that's a bit improved here. Still, as an improvement, what you can do is, for example, make the text rotate if you have more than 32 characters, because here after 32 characters it's going to be truncated. But let's keep things simple for now. Then we have the play buzzer. So with the play buzzer, we're going to do first command.remove, and let's count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's remove 12. And then what we are going to get is, so frequency, comma, duration. But we don't know exactly how many characters this is going to take and how many characters this is going to take. So what we can do is we can focus on this comma. We can find the index of that comma and then take everything before the comma and everything after the comma. And so I'm going to do int comma index is equal to, and you have a function that is, so on the string index of, like this, and you give a character with single quotes like that, it's gonna search for the comma and return the index of the comma. So of course you need to have a comma in the string. And once we have gotten this comma index, now we can do int frequency is equal to command.substring from 0 to the comma index. And we are going to also do dot to int to convert this string to an integer, and then int duration is equal to command.substring comma index plus 1. Okay, because we don't want to actually get the comma in the number, okay? So here we're gonna go from 0 to the comma index, but this is not gonna go until the comma is gonna go just one before, and when we start again, we start just after the comma. To int, and now we have the frequency and the duration. We can do tone buzzer pin with frequency and duration, and that's gonna play the tone on the buzzer. All right, the last command is set LED, and so we've already done that before. So first of all, the command.remove 0, 2, okay, let's count 0, 1, 2, 3, 4, 5, 6, 7, 8, 0 to 8, and then we have something like this, and we need to get red, green, and blue. So we do int red is equal to command.sub string from 0 to, so 0, 1, 2, and 3 dot to int. Then int green is equal to, so we have 0, 1, 2, 3, 4, 5, 6, 7, so 4 to 7. Command.sub string 4 to 7 to int, and then int blue is equal to command.sub string, and we're gonna start at 0, 1, 2, 3, 4, 5, 6, 7, 8 to the end, to 8. Now that we have the red, green, and blue, so let's remove that comment now. We just do analog right RGB red pin with red, and then the same for green and the same for blue, green and blue. You can see now our code is about 100 lines, but it's still quite clear. Okay, we have first initialization, so some defines and some objects we need to create, some global variables. In the setup, we start serial communication. We initialize all the pins, all the components. Okay, we do some setup actions, for example, put the servo in a certain position, print some text on an LCD. And then in the void loop, we have first action, which is to check the push button and send a message to serial. And second action is to process the data we receive from serial. And for each command, we have a different block of code. And well, if you have followed all the previous lessons and activities, you can see that the structure of the Arduino program is almost the same. Okay, that structure that we have here is gonna be almost the same. In the void loop, you have all the outputs, all the inputs, and well, that's pretty much it. If you know how to do this, you know how to do another project. And you can see here there is no relation between any of the components. Okay, this is an independent action, this is an independent action, also this one, that one, that one, everything is independent. The glue or the logic of the application will be from the Raspberry Pi. So now what we can do is we can test this code actually, because how can you know that it's working? Well, you have to test it. Let's upload it to the Arduino. Okay, so we have starting on the LCD screen, and now let's open the serial monitor. So let's check that we still have, okay, starting again. Let's check that we still have the button pressed. Okay. And then I'm gonna do print text. Let's say hello. It's working. Let's print some plus some more characters. Okay, hello plus some more characters on the LCD screen. And anything that I'm gonna write. So here I use actually 31 characters. Everything I'm gonna write after 32 characters is gonna be truncated, but now you can see that it's working. So print text is working. What else do we have? Open door. Let's try open door. So actually the door is closed. Let's do open door. And well, it's working. As you can see here, I had to move a little bit the power, just make sure the power is correctly plugged here. And this is, well, this is a limitation of a circuit that you do with a breadboard and some wires like this, is that of course the connections maybe not 100% stable, okay? So of course, what I recommend is if you try to do this project on a real door is that, well, first you use a different power supply, use external power supply for the servo motor, and then you also, of course, you will need to solder the component, okay? But that's another step. And just here, that was just here to show you that, well, we have some limitations actually with a breadboard, because all those wires, well, at the end you will have something that is not working because something is not correctly plugged. But here, so we have open door that's working. Let's do close door. And okay, it's working. So we have closed door, open door, correctly working. Open door, closed door, print text, play buzzer. Let's actually do something with that. Play buzzer. Let's send, let's say 400 frequency and 500 milliseconds. It's working. Let's send something else like 300 and 1000. Okay, it's correctly working. And set LED. Let's put the red full on 000 and 000. And well, actually we have an error and it's more like white, and well, that's the, of course, if I put the red, which was 255 to each one, to the red, the green and the blue, that's gonna be white, of course. So I need to change that to use the green here and to use the blue here. And let's upload again. Okay, set LED 255 000 000. We have red. Let's do now 000 255. It should be green, and then 000 and 255 at the end. It should be blue. And yes, it is correctly working. All right, so now the Arduino code should be done for the application. So it doesn't mean you don't have to come back to it later on. Maybe you will need to change or to tweak something, because when you program on the Raspberry Pi, you're gonna maybe realize that some stuff on the Arduino should be handled differently, but still we should be pretty safe because we already have defined the protocol. Okay, we have made sure that all the components are working separately and all the commands are also working as expected. And this is the end of this step number 4 for the final project.